I have changed the circuitry around a little bit in the capacitor leakage tester. You may recall it didn't work very well in circuit in the SX62A, and I also commented that the part of the problem was that it wouldn't work on All-American 5 radio capacitors because the output voltage was too high. So I took care of that in a couple of ways, and I'll show you in a minute on the schematic. But here you see the 269 volts that it's putting out in this leakage position. And what I've done is I've added another switch that allows me to use only 110 volts, 111, as you see there. I've added a switch there that allows me to select either high voltage or low voltage. Low voltage, I'm only using the voltage across this capacitor through the resistor to the neon bulb. I've also changed the bulb. I'm using an NE51 and a 470K series resistor instead of the 150K that I had been using. That makes the unit a little less sensitive, and I'll test that in a little bit. But basically the switch that you see on the top of the unit up here now is this high-low switch that you see here. And as I say, it selects either the voltage across this capacitor or across both capacitors. So what you get is the 112 volts in the low position and essentially 270 volts in the high position. So you can test the higher voltage capacitors in one position and the lower voltage ones in the other, and you may notice we still get an indication of leakage with this 11 meg input meter. We'll go to the low voltage position and you will see that let me turn it so that you can see this when I switch it. You notice that the leakage or the voltage goes down, or the current goes down, indicating that there is less leakage current. But of course you'd expect that because there's less voltage. So at any rate, I don't know if this is of any interest to anyone, but if you're building this little leakage tester and you'd like to use it on the All-American 5, you can either permanently wire it to this center, in which case you don't need this capacitor or this other diode. Or if you want to make it switchable between the two, you can do as I did and have the dual supply and then just switch between using just one of the supplies or using the two in series. So that's kind of what I've worked on for right now, but that hasn't gotten me anywhere on the SX62, so that's next. Now I'm ready to replace the elements in this can. There's, you may recall, 3 electrolytic sections in this can. And what I'm going to do is I'm going to cut the can at about this point. I use a saw. A regular hacksaw is sometimes hard to use in these tight places, and of course I removed this tube so that it won't bump into it. But basically I'm going to saw this off. Now, there are occasions where even a saw like this won't work, and you may have to resort to something like a grinder wheel on a Dremel tool or something like that. So let me get on with that and get that opened up so we can replace those electrolytics. I've now sawed the can off, and you see it down here, and now I've inserted a screw in the center so I can get a hold of it to pull out the center. Now, some people use hot air to do this. I will use that to get some of the last of the tar out, but basically these are an aluminum foil with wax and then tar on the outside generally. I haven't pulled this particular one apart, so let's take a look after we've pulled it out. Here is what the capacitor looks like after you've pulled out the center. The screw was here. This used to be in like that, and you'll notice it's a kind of very compact. Actually, this is a little different from the ones that I'm used to, the old vintage capacitors. This is kind of halfway between a modern capacitor and a 1940s or so style capacitor. It's a little better than the 40s, not quite as good as a modern electrolytic. So we got that done. Now we'll clean out the center of this so that we can mount those new electrolytics up on top. And there you see the can cleaned out and sitting on an angle there at the top. Now the next thing is to drill some holes in the top of this that come out at the right locations on the bottom. Before I do that though, I'm going to remove this wax, which is here, and that should make it easier for me to see where to drill the holes. And you see that I've cleaned out the wax there, leaving just the phenolic base, which will be easy to drill through. Now I'll drill 3 holes, actually 4 holes, because I'll want to put the ground lead through one 4th hole, just to make sure it makes good electrical connection. You may notice the ground is actually just a mechanical connection here, and that's okay. But since you can't solder, or at least I can't solder aluminum, I'm going to try to put those ground leads through and solder them to the lugs underneath so I get a good chassis connection. So that'll be next. I discovered something while working on this that I did not realize. You see this little jumper right here that is jumpering this capacitor connection to this one up here. I'm talking about this jumper right there. And what's going on is, it turns out this is not a 3-section electrolytic. I'll try to get enough light on this to show you what's going on. This is actually a 4-section electrolytic. Maybe you can see it there. It says 30, 10, 10, 20. Now the 20 is just a 25 volt cathode bypass capacitor. But the way they get 30 and 20 is they short those two 10s together. In other words, they parallel them. So on the schematic, they show one capacitor on this side and another on the other with the filter choke in between, and those are 20 and 30 microfarads respectively. But this 30 on this side is really 2 capacitors paralleled. This is not the parallel capacitor here. This is actually a bypass capacitor, which is right there, that is going to ground. It's an additional filter on the line, I assume, to bypass high frequency currents, since it's a very low value compared to the electrolytics. Okay, so anyway, now we can go about drilling our holes and putting the capacitors in and all of that, and then hopefully we'll be ready to go with a power up pretty soon. Now I'm putting together the capacitors, the 30 and the 20 microfarad capacitors, to go inside that can. And you may notice what I've done is I have hooked the negative leads together. That's this lead. That will go up the middle of the can. That is, there's a hole in the center, a vent hole in the center, which that lead will go through. And then these I'll drill holes in the sides of the can, that is near the edges of the can, to go through these two. So now I'm going to solder this internally and then install these 2 capacitors, and I'll show you that when I get back over to the chassis. And here is the assembled unit ready to go in, and you'll notice that I've put a small black wire on the center terminal, that is the 2 negatives. that will go through the center of the can. I'll show you that here in a second. And here you see the can. There's one of the holes is down here, one is up there, and then there's the center hole that the ground lead will go through. Okay, I'm now set with about 115 volts into the unit with those capacitors installed. And over here you see that the B plus is about 262 volts. And over here you can see that there are some dial lights that are on and a few other indications of something going on. So I think at this point the next thing I'd like to do is check some voltages and some resistances. I have some charts that look like this. This is the resistance chart. And what I'm going to be doing is going around and checking each tube, each pin of each tube against this resistance chart. Of course, that's done with the power off. And then, with the power on, I will check each of them for the voltages shown on this chart. And once again, this will be on each pin of each tube. And I'll show you how I do that when I get to those points. But basically, the capacitors are now installed. Okay, there they are. I had to move the camera a little closer and get some of that background out of there so that the autofocus would work. So basically, the can will now go over the top of these two capacitors, and then I will attach it with some aluminum tape. But for now, I'm going to leave the capacitors open. There's no point in putting the tape on until I'm ready to bundle everything up, because that's mostly just for cosmetic purposes, and if something goes wrong and I have to replace those capacitors, it would be a lot easier to have the top off. So we'll do that. We'll go through the resistance checks, then the voltage checks, and hopefully at that point we'll have something that will actually come to life, and maybe we can start doing some work with it, alignment, things of that sort. So that's where we're headed. And in case you were wondering why that when I was working on this capacitor down here, that I wound up only replacing two sections. Well, you may recall that it was a 4-section capacitor, but 2 sections were already wired together. 2 10 microfarads to make a 20 microfarad. Then there was a 30, but there also was a 100 microfarad, a 20 microfarad, 25 volt capacitor, which was also a part of that same unit. It's called C111. That's this one right here. That is off of the cathodes of the audio output tubes. These are in push-pull. And what I had decided to do there is, rather than mount the capacitor down in there, that it would be more useful, both physically as well as electrically, if you mounted it down here at the 6V6s. So that's what I'm going to do next, is I'm going to mount that capacitor. That's the cathode bypass capacitor. And that way it will be as close to the actual audio tubes as possible, which should provide better electrical bypassing than having a very long wire. You may notice that from there, the wire going to that capacitor has to go up into that bundle, and then along this bundle here, and then all the way up there, and then it connects to the capacitor. So what I'm going to be doing is removing that wire, disconnecting it actually on this end down here, and putting the capacitor right from the cathode to ground, right at the 6V6. And there is the final capacitor. You see shunted right across the cathode resistor. Notice it's a 20 microfarad, 160 volt capacitor. Now it only needs to be a 25 volt, but it can't hurt. And one reason I'm using the 160 volt is it's a little more resistant to temperature. This is a 105 degree capacitor, and it's much larger as well, so it can dissipate more heat. You may notice the resistor next to it, the cathode resistor, is a 2 watt resistor. Now, modern resistor would be a lot smaller than that, but that's the way they were back in the day. So we've got that all paralleled up, and everything should be ready to do those voltage and resistance checks. The first tube we're going to check for resistance is the 6C4 that you see there. It's the first one in the chart. And you see pin 1, it has 500 k ohm. That's because that's a capacitor that charges up. So what we're going to do, just for purposes of illustration, is I'm going to use pin 2. And you may notice that what I've done is I've put a socket extender in there. You can get these on eBay if you look around a little bit. They come in different types. This is a 7-pin, and over here in the box are some octal and some 9-pin and so on. And we're now going to check pin 2, which you notice says 0 ohms. And when we go up to the chart, 6C4 pin 2 should be 0 ohms. So that's what we're going to be doing, going down through this chart. We're going to go across on each tube, each pin, and then do all the tubes down here. I'm not going to bore you with showing you each reading. Instead, what I'm going to do is go through it. If I find something that's unique or a little out of the ordinary, well, I'll video that. Otherwise, the next part, I'll just skip straight to the voltage checks. None of the resistance readings were far enough out of range to cause much suspicion. So I'm beginning to do the voltage checks, and one of the first things I did, you may notice that 6V6 there is up on an extender, and I have a clip lead hooked to pin 3. The purpose of that is to set the voltage. This is the 6V6 here, and if you'll notice, pin 3 is 270 volts, and then pin 4 is 240 volts. So what I wanted to do is to set the AC line voltage to the value that caused 270 volts on that pin. And the reason for that is that's the basic B plus voltage going to the audio section. And if you set that one to the same value that the person who prepared this chart had, then your conditions are the same, and the other readings should be in line with that. So now I'm going to go through and check voltages on tubes throughout the set, see if there's anything that's far out of line. Now, you may consider this overkill, and it really is overkill in this particular situation, but the reason that I'm doing it is partly to see if there's anything about this chart that is unreliable, that is vastly different in, say, this set than in the set that the person who made this chart was using. And I'm going to keep my reason for that behind the scenes for a little while, and then later in this series I'll explain why I'm trying to verify these charts. But anyway, that's what I'm doing, and I'll be going through once again. I won't show you all the voltage readings. I'll just look for any that are very far out, and if so, I will note them and perhaps do a little video on those differences. I have run into one reading on the 6V6. The cathode is reading about 18.7 volts. The chart shows that it should be 14.5 volts, Now, one thing I should point out, these readings were taken from an SX62, not a 62A, and there are circuit differences. I think I've shown you some of them, different tubes, and perhaps some other changes that not really aware of yet, but nonetheless, 18 volts where I should be getting 14. It looks a little bit suspicious. That's on pin 8 of that 6V6. And so I'm going to be doing a little investigating to see why, because that indicates that those 6V6s are drawing a little bit more current than they were in this set. So I'll be back if I find anything. I turned the set off and measured the resistance to ground of that cathode, and it reads 245 ohms. Now that is a little higher than the 220 ohms that the chart shows, but 220 is the nominal value for that resistor, and it's not unusual for the resistors of the time to vary. In fact, a 20% tolerance resistor could be up to 265 ohms, a 220 ohm resistor that is. 20% would add 44 ohms of resistance if it were, say, 20% over, and that would still be within tolerance. So 245 is still within 20%, but it's right on the edge of 10%. And so what I'm going to do is reduce that resistor by putting one in series or in parallel with it to reduce its total resistance to 220 ohms, and then see what that voltage reads. It may be that I'll replace that resistor just to lower the total current through that tube, because as the tube conducts more, of course, it'll get hotter and all sorts of things. But I'm going to look at that and see what's the best approach. But basically, I'm going to see how close to the 14.5 volts I get with a true 220 ohm cathode resistor. Well, I paralleled up that resistor to see if the voltage would go down, and it did. If I put enough resistance in parallel with that 245 ohm resistor to bring it down to 220, I get about 15.5 volts, which is close enough to the 14.5 that this chart shows that I'm happy. But the real reason why I've been doing all of that is that I've been sort of hiding something from everyone. My brother knows about this, but I think everybody else that watches these probably doesn't yet. The reason that I've been doing the restoration on this set is that I actually have another one, and I wanted to handle this set differently. Instead of doing a restoration, in other words, replacing all the caps and so on, what I wanted to do is treat this set as a repair. In other words, if it came into the shop and somebody said it doesn't work, and you have to get it working with the minimum cost, in other words, the fewest replacement parts, which is really what would have happened back in the 50s or 60s. And it was something that I really always enjoyed. So I have to admit, this is a little bit of nostalgia, well, a whole lot of nostalgia. But if one of these SX62s had ever come into the shop that I was working in high school, none did. Nobody in our community was rich enough to afford these. But I would have loved to have worked on one. So I'm sort of reliving my youth here. But here's the situation. I was hoping, when I turned this set on, that there might be some problem with it, so I could troubleshoot it and work on it as though it was a repair. However,
those are two good things to do for anxiety.
Except for a noisy volume control.
Personal anxiety. I'll be praying for you, Mary. Let's see, I got one here from Gary. I wonder, are you familiar with the Essenes?
As you can tell.
It's a problem of mine. Essenes Gala, they're people. I was given a book by a friend, The Writer's Reading Subject. The book is
Well, I hope you'll pardon the static. I need to clean that control, but except for that, I'm afraid this set completely works. So, since I've already revealed the secret, I'm now going to go over and show you this other set. There's the one we just were looking at. This is the one I've been working on, and the one with the rebuilt controls, rebuilt knobs.
There's traditionally thought to be the name of our Blessed Mother's mother, and so we would put as saints. Those are the names that we received from an ancient tradition, and so we stick with them. More than that.
Now, as you can see, this one works too. Now, there's no antenna connected. In fact, watch what happens when I touch the antenna.
We're going to a break. More of the exciting details about today in our pledge drive.
See, the volume comes up a little bit. So, my hope that at least one of these would have a problem that I could troubleshoot is gone. That's the bad news. The good news is they both work. So, I'm going to speed up from here and try to get on to tuning these up. Obviously, this one needs a lot of cleanup. Not just cosmetic cleanup, but things like the pots that are dirty, and I'll need to clean all that up. But at any rate, the secret is now out, and you see why that when I started this, I said I referred to this as my secret shop. It's not that it's a secret, it's just that there was a secret hiding out here, which is that I was actually restoring two of these. I'm going to end part 6 at this point, and then go on to some more stuff in part 7. By then, I hope I'll have all the controls on this one hooked up, and I'll turn this off so you're not bothered by all that noise. And at that point, I'll be working on both of these side by side, comparing voltages and things like that. And that is the reason why that I wanted to get these voltage charts, is to find out where there are differences between these two sets. Voltage readings is primarily the place that I'm looking. So anyway, end of part 6. In a few days, maybe a week or so, I'll get on to part 7 after I've had a chance to clean up this chassis a little bit and restore some of the switches and controls and get them cleaned.